Hello, my project today is MCS1001, and my project name is the Utilization of Generative Neural Networks to develop novel molecules to target Leishmaniasis. Leishmaniasis is a neglected tropical parasitic disease that kills millions of people in poor, undeveloped countries. Those that suffer from this disease cannot afford expensive drugs as the research and development cost is too high, which means they cannot justify development. The solution to this is AI, which drastically decreases research cost, as well as allowing for cross-referencing of large amounts of data in a fraction of the time. The next step was to choose a specific pathway to kill the parasite. This approach is needed because AI's strength is in specializing in niche areas, where limiting the problem is always a plus. I connected with Dr. Benjamin Perry at DNDI, Drugs for Neglected Disease Initiative, who helped me choose methionyltyrannase synthetase, which plays a key role in protein synthesis that keeps the parasite alive. This target also has a lot of prior data which is needed to help the neural network learn the chemical space. Next, I needed to decide on the neural network architecture to use. After some research, I ended up adapting the neural network Generative outlined in Dr. Alex Zakharnov's paper, where they used Generative to successfully create novel molecules for DDR1 kinase. This model works in two parts. First, it looks at the prior chemicals and generates different features and attributes for them. In the second step, it tweaks those features to maximize different rewards, generated through graphing prior data in self-organizing maps. The rewards I used were potency, ease of manufacturing, and druggability. After weeks of training the model on my computer, it was able to generate promising molecules. They had a maximum potency of 93% and a 2.8 accessibility score, implying significant synthesizability for a bioactive molecule. I showed the final output to an expert discovery chemist, and they said that the molecules looked feasible to create and were sufficiently complex to warrant bioactivity. This shows I was able to complete my goal successfully. I'm currently reaching out to DNDI to gauge moving this project to synthesize and test for activity in the future.